In 4.6, we're going to be talking about imaginary numbers, and I would say the most important thing you can remember, and I'm going to write it over here so you can just have it the whole video, is an imaginary number is equal to the square root of -1. So anytime you have a square root of a negative number, you can take out an I, and something else to remember is that I squared equals -1. So that's really how we're going to do this whole assignment. So let's start talking about it. So let's say we have the square root of a negative number, like the square root of -r. The answer is imaginary number times r. So, for example, if we have the square root of -3, what that really means is square root of -1 times square root of 3, and that means I times the square root of 3. In the same way, I'll show you how to solve a problem like this. So 2x squared plus 11 equals -37. So subtract the 11. Notice there's no normal x term, there's only x squared. So we're just going to get everything away from it. So subtract 11 to get to -48 equals 2x. Divide by 2 to get -24. Now we're going to take the square root. So x equals the square root of -24. And what that means is we can take out an I right away. Now we just have 24. We have to clean it up a little bit. So 24 is square root of 4 times the square root of 6. So that's a 2, that's a 6. So 2i plus or minus 2i, square root of 6. Let's try another couple examples. So x squared, or let's say we have x squared is equal to -13. So we'll take the square root of x squared, square root of 13, -13. We get x equals plus or minus I times the square root of 13. We can't reduce the 13 anymore. Let's say we have the example x squared plus 11 equals 3. Okay, subtract 11 to get -8. Take the square root of both sides. We have x equals plus or minus 2i times the square root of 2. That's because -8 is really -1 times square root of 8, and 8 can be broken up into 2 times 2 times 2. We can take out one of those 2's to get plus or minus 2i times the square root of 2. Now, imaginary numbers aren't real numbers, they're imaginary, but they do exist. You just need to use your imagination. And since they exist, they can also fit on a coordinate plane like this. They just have a completely different one that they fit on. So on the imaginary number coordinate plane, this is -I down here. This is +I. And these are real numbers, left and right. So this is real, and this is imaginary. Now usually we're used to seeing x and y, but on the imaginary and real number coordinate plane, real numbers go to the left and right, imaginary numbers go from top to bottom. So let's say we have a number like -3 minus 2i. Well, we're going to go -3 on the real, and we're going to go minus 2i on the imaginary, and it exists here, -3 minus 2i. What if we have, okay, 2 plus 2i? Well, 2 on the real, go up 2 on the imaginary, so this is 2 plus 2i. Okay, you also need to know how to add and subtract complex numbers. A complex number is like what I just showed you. It's any number in the form a plus bi. So let's say we're adding these complex numbers, 7 minus 6i, or we're subtracting them, minus 3 minus 6i. So all we're going to do is combine the ones we can. So we can't combine real and imaginary numbers, so we can only combine the ones we have. So 7 minus 3 is 4. -6i minus -6i, so -6i plus 6i is 0. And so our answer is just going to be 4. Okay, let's say we want to do 8 minus I plus 5 plus 4I. Okay, the 8 plus the 5, we can do that to get 13. Negative I plus 4I, it's plus 3I. And that's our answer, 13 plus 3I. Okay, sometimes we're going to multiply them together. So I'll show you how to do that. So let's say we have 4I times negative 6 plus I. We're going to distribute in, just like you would expect. We get negative 24I plus 4I squared. Now, we're not done yet. Like I said before, I squared is equal to negative 1, so we have negative 24I plus 4 times a negative 1. So we're going to move this term out front, so that's negative 4 minus 24I. Because a complex number is written in this form, A plus BI. So negative 4 minus 24I. You also need to divide these. And this is done very similarly to the square root division that I showed you in 4.5. So let's say we have 7 plus 5I over 1 minus 4I. Now we don't want imaginary numbers in the denominator, just like we don't want square roots in the denominator, so you do the same thing. You multiply times the opposite of it, 1 plus 4I on the top and the bottom. Of course, that doesn't change it at all. We're just multiplying by 1 over 1. Here's what we're going to get. 1 times 1 is 1, plus 4I, minus 4I, minus 16I squared. On the top, we get 7 plus 28I plus 5I plus 20I squared. Now we need to clean this up a little bit. I'm going to change my color so you guys can follow along. Just clean it up a little bit. Okay, plus 4I minus 4I goes away. And that's why we multiply by the opposite here, so that happens. Remember, 16I squared is equal to negative 1. So negative 16 times negative 1 is actually positive 16. So 1 plus 16, we get 17 on the bottom. Okay, on the top, we get 7 plus 28 I plus 5I, that's 33I. Remember, I squared is negative 1, so 20 times negative 1 is negative 20 plus 7. So we get negative 13 plus 33I all over 17. And we can separate this a bit to get negative 13 over 17 plus 33 over 17I. And that's our final answer. In the form A plus BI. The last skill you need from this section is to find the absolute value of a complex number. So let's say we have a complex number A plus BI. To find the absolute value of that, all we're going to do is something really strange. We're going to take the square root of A squared plus the number B squared, and we're just going to completely forget about that I. So let's say we have an example. Okay, we have a complex number negative 4 plus 3I. We want to take the absolute value of that. We're going to plug it into this equation. Square root of negative 4 squared plus 3 squared. See what we get here. So negative 4 squared is 16, plus 3 squared is 9. That's 25, so the answer is 5. And of course, you know it's plus or minus 5. Okay, so just to recap really fast what we did in this lesson, we learned that anytime you have a negative number under a square root, you can take out an I and make that number positive. Anytime you have I squared, that really just means negative 1. We went over how to add and subtract complex numbers in the form A plus BI. We learned how to multiply them. We learned how to divide them. We learned how to take the absolute value of a complex number. and I showed you how to graph a complex number on a plane like this, where it goes from imaginary up here to negative imaginary, real numbers, positive and negative go on the x-axis.